Stand anywhere. Hold out your hand, you'll feel at rest. The ground seems solid, unmoving. The sky feels calm, yet almost everything about your situation is an illusion. You are spinning right now at hundreds of meters per second as Earth rotates. You are also racing around the sun at 30 kilometers per second. The sun itself is orbiting the center of the Milky Way. The galaxy is turning. Galaxy clusters swirl. Even atoms deep inside your body refuse to stay still. Spin is everywhere. This is not poetry, it is physics. And it leads to one of the strangest, most persistent questions we can ask about reality. Why does everything in the universe rotate? Why don't things simply move in straight lines and come to rest? Why are disks, spirals, vortices, and orbits the rule rather than the exception? Richard Feynman, one of the most brilliant and unconventional physicists of the 20th century, was obsessed with questions like this. He distrusted fancy words and shallow explanations. When someone said, "That's just how nature works," Feynman heard alarm bells. Nature, he believed, always has a reason, even if that reason takes us far beyond common sense. This story begins with a simple observation, but it will pull us from spinning teacups to rotating galaxies, from the birth of stars to the structure of space-time itself. To understand why everything spins, we must first confront a deeper truth. Motion is not something added to the universe. Motion is what the universe is made of.
The world that should have stopped.
Imagine a universe built the way our intuition suggests. Things move only when pushed. Friction slowly bleeds motion away. Eventually, everything settles down. This idea feels obvious because it works on Earth. Kick a ball and it rolls for a while, then stops. Spin a top and it wobbles, slows, and falls over. Pour milk into coffee, stir it, and the swirling patterns fade into stillness. Rest, not motion, seems natural. But this view is profoundly wrong. Entry. So that is a global thing. Feynman loved pointing out that friction, the reason motion dies on Earth, is not fundamental. It is an accident of our environment. Air drags on objects. Surfaces scrape against each other. Energy leaks into microscopic gradations and heat. Remove those effects, and the universe behaves very differently. In deep space, there is no air to slow a spinning object, no table to rub against. Once something is rotating, it keeps rotating. Not for minutes, not for centuries, for billions of years. This is not a strange special case. It is the baseline. Stillness is the exception. The laws of physics do not demand that motion fade away. They demand the opposite. That it tried Newton's uncomfortable discovery for centuries. Nobody understood how planets moved. Newton's first law of motion, often glossed over because it sounds simple, states something revolutionary. An object in motion stays in motion. An object in motion stays in motion unless acted on by an external force. The same applies to rotation. This means the universe does not naturally prefer rest. If anything, it prefers persistence. Spin is not something that needs constant encouragement. Spin is something that must be stopped. When Feynman discussed inertia in his lectures, he emphasized how deeply weird it is. Why should an object resist changes in its state of motion? Why does matter care about its speed or rotation? Physics can describe inertia with exquisite precision. What it cannot do, at least not yet, is explain why it exists at all. And inertia has a partner that makes rotation unavoidable: conservation of angular momentum.
The law that forces the universe to turn.
Dit underground stadig. Angular momentum sounds technical, but its core idea is brutally simple. If something is spinning and no external torque acts on it, then the total amount of spin stays the same. You have seen this law in action, even if you never named it. A figure skater begins a slow spin with arms extended. When she pulls her arms in, she spins faster. No magic, no extra energy. The same angular momentum concentrated into a smaller space. Feynman adored this example because it is honest. Nothing mystical is happening. The universe is simply obeying a bookkeeping rule. Now apply this rule to the cosmos. When a cloud of gas collapses under gravity to form a star, it almost always starts with a tiny, barely noticeable rotation. That rotation might be unimaginably small, a trillionth of a turn per year, but it is not zero. As the cloud collapses, it shrinks, and as it shrinks, its rotation speeds up. The result is a spinning star. Planets form from the leftover material in a rotating disk. Moons form from rotating debris around planets. Galaxies condense out of vast rotating clouds of matter. Black holes spin so violently that space-time itself is dragged around them. Nothing had to tell these systems to rotate. Once rotation existed, even in the faintest trace, it could never vanish. Why? Nothing starts perfectly still. At this point, an obvious question arises. If rotation is conserved, then where did the first rotation come from? Why wasn't the early universe perfectly balanced, with zero spin everywhere for centuries? Nobody understood how planets moved. Copernicus said they orbit the sun. Fine. But how? What paths do they follow? Tycho Brahe built an observatory and spent decades recording planetary positions, night after night, year after year, measuring angles with brass instruments to fractions of a degree. Why such precision? Because Japan understood how planets moved. Copernicus said they orbit the sun. Fine. But how? What paths do they follow? Tycho Brahe built an observatory and spent decades recording planetary positions, night after night, year after year, measuring angles with brass instruments to fractions of a degree. In theory, you can imagine a cloud with no net angular momentum at all. In practice, the tiniest imbalance ruins the fantasy. A single extra particle drifting slightly to the left instead of the right. A microscopic temperature difference across a region of space. A random quantum fluctuation. Any asymmetry, no matter how small, creates angular momentum. And once it exists, the conservation law locks it in forever. The early universe was hot, dense, and violent. Particles collided, decayed, and scattered. Quantum mechanics guaranteed fluctuations. Absolute stillness was not merely unlikely, it was forbidden. Feynman's teacup experiment. Feynman often illustrated deep physics with absurdly simple experiments. One of his favorites involved a cup of tea. Stir the tea, he said, and watch the leaves gather in the center of the cup instead of flying outward, as you might expect. At first glance, it seems wrong. Centrifugal force should fling the leaves to the rim. But friction between the liquid and the bottom of the cup slows the water. The slower water creates a pressure gradient that pushes the leaves inward. This humble observation reveals something profound. Rotation creates structure. Spinning systems naturally sort themselves, form patterns, and concentrate matter in specific ways. The universe does the same thing. Galactic disks flatten because rotation and gravity negotiate a compromise. Accretion disks glow because friction converts orbital motion into heat. Spiral arms appear because rotating matter is never perfectly uniform.
The spin is not deformation. It is the mechanism.
Quantum secret, spin without spinning.
So far, every example involves objects physically rotating in space. But nature goes deeper. In quantum mechanics, particles possess a property called spin that has no classical counterpart. An electron behaves as if it is spinning, yet it cannot literally be a tiny rotating ball. If it were, parts of it would move faster than light. Spin, in the quantum sense, is built into existence itself. Feynman emphasized that this is not a metaphor. Spin is not caused by motion. Spin is fundamental. Particles come with it the way they come with mass or charge. This discovery demolished the last refuge of stillness. Even when nothing is moving through space, even when a particle sits in its lowest energy state, it still carries angular momentum. Motion has penetrated reality at its deepest level. Rotation and the arrow of time. There is another reason spin matters, one that edges dangerously close to philosophy. Rotation is tied to irreversibility. Spinning systems tend to transfer energy, create turbulence, and increase entropy. They mix, they evolve, they refuse to rewind cleanly. For centuries, nobody understood some new fear. Feynman suspected that the prevalence of rotation is not an accident layered on top of time's arrow, but part of its machinery. The universe does not just expand, it twists as it goes. And once twisting begins, there is no going back. A universe that cannot help itself. By the end of his life, Feynman was convinced that asking why everything spins is really asking a more dangerous question. Why does the universe allow anything other than nothing? A perfectly still universe would be sterile. No stars, no chemistry, no life. Spin breaks symmetry. It creates gradients. It gives gravity something to work with. In that sense, rotation is not a side effect of the universe. It is a prerequisite. In part 2, we will push deeper into how gravity manufactures rotation on colossal scales, how galaxies remember motions from the earliest moments after the Big Bang, and how black holes turn spin into energy. The universe, it turns out, does not merely spin. It runs on spin. Gravity does not pull straight. We are taught to imagine gravity as a simple force. Things fall straight down. Apples drop. Planets go around the sun. Objects attract each other. But this picture hides a crucial truth. Gravity almost never acts on objects that are perfectly aligned. In the real universe, matter is lumpy, uneven, and slightly off-center. When gravity pulls on such matter, it does not pull straight inward. It pulls at angles. Those tiny sideways components of force, imperceptible at first, are enough to generate rotation. This is how spin is born on the cosmic scales. A cloud of gas drifting through space does not collapse like an elevator falling down a shaft. Different parts of the cloud feel gravity from slightly different directions. Some regions fall faster, others lag behind. The result is shear, torque, and ultimately rotation. Feynman emphasized that gravity is not a clean force. It is messy, and messiness is exactly what produces spin.
The birth of a star is the birth of a disk.
Every star tells the same story. Astronomers observe vast clouds of hydrogen collapsing under their own weight. As collapse begins, the cloud flattens into a disk. At the center, matter heats up. Nuclear fusion ignites. A star is born. The disk is not optional. Without angular momentum, the cloud could collapse directly into a point. But angular momentum blocks that path. Matter cannot fall straight in because it is already moving sideways. So it circles. Planets condense inside these spinning disks. Their orbits trace the memory of motions that occurred millions of years earlier in a cloud light years across. Rotation is memory. The solar system still remembers how its parent cloud happened to twitch before the sun even existed. Why galaxies become spirals. Look at the night sky through a large telescope, and spiral galaxies dominate the view. Their shape feels intentional, almost artistic. Not. A galaxy begins as a diffuse collection of gas and dark matter. After the Big Bang, gravity pulls it together. As matter falls inward, tiny rotations are amplified. But here is the key insight. Spirals are not rigid structures. The arms of a galaxy are patterns, not objects. Stars move in and out of them, like cars passing through a traffic jam. The pattern persists even though the individual stars constantly change. Feynman loved these systems because they show how rotation creates order without design. A spinning galaxy organizes chaos into structure simply by obeying conservation laws.
When dark matter, the invisible hand on the spin.
Galaxies rotate far faster than visible matter alone should allow. If only stars and gas were present, galaxies would tear themselves apart. Something else is holding them together. Dark matter does not emit light, but it carries mass, and mass carries gravity. Enormous halos of dark matter surround galaxies, guiding their rotation. Here is the unsettling part. The spin of galaxies today depends on how dark matter moved billions of years ago. Rotation is a fossil record. Every swirl in the cosmos encodes information from the early universe, preserved by angular momentum like a fingerprint in stone.
Black holes when spin breaks reality.
If rotation were merely common, black holes would still be strange. But rotating black holes are something else entirely. When a massive spinning star collapses into a black hole, its angular momentum has nowhere to go. The black hole inherits it. The result is a black hole in object that does not merely sit in space, but drags space itself around with it. This effect, called frame dragging, means that near a spinning black hole, nothing can remain still. Space and time swirl like water in a drain. Feynman suspected that rotating black holes exposed the deepest link between motion and geometry.
Spin is no longer happening in space-time.
Spin is reshaping space-time.
Hidden energy from spin.
Rotation is not only persistent, it is useful. A spinning black hole contains vast reserves of energy locked in its motion. In theory, and likely in nature, that energy can be extracted. Astrophysicists believe that the most powerful jets in the universe, blasting from the centers of galaxies, are powered by black hole spin. Magnetic fields tap into the rotation and convert it into beams of matter, traveling near the speed of light. The universe runs engines that no human technology could survive. Spin is the fuel. Why the universe never forgets. Once angular momentum appears, it cannot be erased. Illusions can redistribute it. Friction can hide it in microscopic motion. Radiation can carry some away. But the total remains. This is why the universe remembers its past so well. Long after temperatures cool and structures disperse, rotation persists. It outlives stars. It survives violent mergers. It endures explosions. Feynman liked to say that nature keeps its accounts perfectly. Spin is one of the oldest entries in the ledger. Could the entire universe be rotating? This question disturbed physicists for decades. Is it possible that the universe itself is spinning? General relativity allows such solutions. A rotating universe would imprint subtle patterns in the motion of galaxies and in the cosmic microwave background. So far, observations suggest that if the universe is rotating, it is doing so extremely slowly. But the idea refuses to die, because if the universe does rotate, then all local spins, planets, stars, atoms may be connected to something global. which leads to a dangerous idea. Mach is whisper and Feynman's unease. Ernst Mach proposed that inertia itself arises from the distribution of mass in the universe. In this view, an object resists rotation because the rest of the universe is there. Feynman was deeply unsettled by this possibility. If Mach was even partly right, then spin is not a local property at all. It is relational. You spin relative to everything else. The universe, in some sense, participates. By this point, a pattern is impossible to ignore.
Gravity amplifies tiny asymmetries. Angular momentum preserves them. Rotation organizes matter, stores energy, and reshapes space-time.
This spin is not cosmetic.
It's questions about Brennan's moon.
It is infrastructure. The final layer will fall into place. We will move inward to quantum fields, vacuum fluctuations, and the unsettling reason absolute, stillness, may be physically meaningless. The mind-boggling truth Feynman hinted at waits there.
And it is stranger than spinning galaxies, the lie of absolute stillness.
If you strip the universe of stars, planets, gas, and light, what remains? Common sense says nothing.
Physics says a seething storm.
Even in perfect darkness, even at absolute zero, the universe refuses to sit still. Quantum fields fluctuate. Particles appear and vanish. Energy sloshes through empty space. Stillness is not the natural state of reality. It is a myth invented by human intuition. Feynman loved reminding students that nothing in physics behaves the way common sense expects once you look closely enough. The deeper you go, the more motion you find. Fantasy built in. Chapter 24.
Was built in
the quantum mechanics. Spin is not something particles acquire. It is something they are.
Electrons, quarks, photons, all possess intrinsic angular momentum. This spin does not involve literal rotation in space. It emerges from the mathematical structure of quantum fields. Feynman emphasized the unsettling implication. You cannot remove spin from the universe without destroying matter itself. Even a single isolated particle carries angular momentum, even if it is perfectly cold, even if it is alone in empty space. Motion survives every attempt at erasure. Zero-point motion. The universe cannot rest. Quantum theory predicts that systems retain motion even in their lowest energy states. This is called zero-point motion.
The organs vibrate even at absolute zero. Fields fluctuate even in vacuum. Particles jitter forever.
If everything truly stopped, quantum uncertainty would be violated. Position and momentum cannot both be fixed. Nature forbids total rest. Feynman often joked that the universe is not lazy. It refuses to settle. Spin is one expression of this refusal.
The vacuum that spins back.
The vacuum is not passive. The vacuum is not passive. According to quantum field theory, empty space reacts to rotation. Accelerate or spin an object through vacuum, and it responds as if filled with particles. This is related to effects like Unruh radiation and vacuum polarization. The lesson is disturbing. So disturbing. Rotation is not happening in nothing. Rotation is interacting with something real. Space itself participates. Why does the universe prefer motion? Because perfect symmetry produces nothing. If the universe were perfectly balanced, no direction would be special, no change could begin, no structure could form. The early universe broke symmetry, not accidentally, but inevitably. Tiny fluctuations were enough. Once broken, conservation laws preserve the consequences. Spin is frozen asymmetry. It is the scar left behind when the universe chose to exist.
I see discomfort with final answers.
Feynman distrusted explanations that sounded complete.
Whenever physicists claimed to have reached the bottom, he suspected another layer waiting below. Why does angular momentum exist at all? Why do conservation laws rule reality? Why does mathematics describe nature so well? Feynman admitted openly that physics has no final answer to these questions, only better and better description. But he did suspect something crucial. The laws of physics are not rules imposed on the universe. They are habits the universe cannot break. Spin is one of those habits. Electrons.
What? You said.
From the final wars, with the ecstatic shock said, Selta. The rise democracy brukar. That's to say that when Charlotte comes to the panic shorty,
Charlotte takes the princess, said we can take out hand for singing a date. How fit Charlotte with if I have to take a step up. What? You gather me? Charlotte? Charlotte, who's far in debate. Debate. Hop. 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 Yes. Yes, Philip. Hop.
The universe as a quantum dance. At the deepest level we know, reality is not built from objects, but from interaction. Fields vibrate, particles exchange momentum. Information flows. Rotation is not secondary to this process. It is woven into it. Without spin, atoms would not have structure. Chemistry would not exist. Magnetic fields would vanish.
Where could it be?
Life would be impossible.
The universe does not merely allow rotation.
It depends on it.
It depends on it.
The final, mind-boggling truth. Feynman never framed it this way, but his work points to a radical conclusion. The universe spins because it cannot do otherwise. Motion is not a feature layered on top of existence. Motion is existence. A universe without spin would be a universe without memory, structure, or time. Stillness would mean nothingness. Why? You are never still. Your atoms spin. Your electrons carry angular momentum. Your planet rotates. Your galaxy turns. You inherit motion from the universe itself. When you stand still, you are participating in a dance that began billions of years before Earth formed. The universe is not a clock that can stop. It is a whirlpool that can never unwind. The unfinished question. For centuries, nobody understood how planets moved. Copernicus said they orbit the sun. Fine. But how? What paths do they follow? Tycho Brahe built an observatory and spent decades recording planetary positions, night after night, year after year. Why does the universe exist at all? Why these laws instead of others? Why motion and not eternal silence? Physics has not finished the story. But one truth is clear. Everything spins because the universe itself He's restless. And it always has been.